Okay, so let's start our introduction to the paper McGuire and Styling 1983. So first I will give an introduction about what this paper wants to talk about, and then the model they used, and then the first part of our analysis will be the pricing games we want to discuss in this paper. So, as we mentioned, the key question in the distribution channel selection is about the number of intermediary you want to use when you distribute your products. For example, if you sell through a company store, the, the company store is owned by yourself, then that somewhat means a zero level of intermediary. That means you integrate this channel. Or if you want to delegate to a franchise store or an independent retailer, in that case you create one level of intermediary, and that means you are doing decentralization. In this paper, the authors want to discuss about the selection between 0 or 1 levels of intermediary. Okay? And in particular, the intermediary or the retail store, the one who is selling the product, is assumed to be no stronger than the manufacturer in the selling business. Okay? If I delegate to a retailer, he is not going to be more capable of selling products than me. Okay? I can do as well as him if I want to operate my own company store. So that's the meaning. The intermediary is assumed to be no stronger than me. Then the paper will tell us a reason about inserting one level of intermediary. So about every research must have its scope, and in this paper, they only discuss the situation in which there is only exclusive retail stores. That means the retail store sells products only from one manufacturer. It's not like those retailers we see on streets. Okay, typical retailers such as 7-Eleven or some other guys, they sell products from multiple manufacturers. But here we discuss exclusive retail stores, and the particular examples are company stores and the franchise stores. Okay, you may imagine that you are the manager of McDonald's, and you are asking whether you want to at a particular stage at a particular place. You are asking yourself whether you want to open a company store or let someone to run the store. That means a franchise store. That's the question. They are comparing these two possibilities. And when do we see this kind of exclusive retail stores? In the paper, they mentioned about, for example, gasoline, okay, new automobiles, fast food restaurants, and many, many more. Okay, or at least in the United States, these industries provide examples about exclusive retail stores. People may want to get franchise for example, one brand of gasoline, one brand of automobiles, one brand of fast food, and so on. Okay, so indeed, there are some situations for us to see exclusive retail stores. That's what talked about in this paper. The model is an extension of bilateral monopoly. This may be the first time for you to see this term, and that somewhat means that's a producer and distributor relationship, or you may think about the manufacturer-retailer relationship, in which each party enjoys monopoly. The producer is the only guy producing this product, and the distributor is the only one selling this product. So at two sides, there are monopolies. Okay, and this model is an extension of bilateral monopolies because now we have, in some sense, two channels. Okay, in each channel, there is a manufacturer, there is a retailer, and there are some kind of competition. This paper searches for conditions for the industry equilibrium to be have 1 or 0 levels of intermediary. So that means we do not assume a given industry structure. The level of intermediary is not fixed. It is chosen by those firms, and firms will make their selection according to their profits. Firms will find the channel structure that can maximize its profit, and certainly such choices is based on the decentralized manner. Okay. So we probably need to first define what kind of industry structures are possible and what are the business environments. So let's talk about it. There are two manufacturers in this industry and they are selling different but substitutable products. Okay? Remind yourself about Bertrand game we mentioned in class. So in Bertrand game there's one coefficient, if you remember, theta. And that theta measures how these two products may substitute each other. Okay? When these two products are very similar, then that coefficient would be very high, and we say they are highly substitutable. Okay? So it is assumed that these two manufacturers are price setters, and the demand for each product will be affected by both prices. Okay? And eventually we will see if both of them choose not to use an intermediary, they will play the Bertrand game. Okay, so substitutor products, price setters. Each of them may independently decide whether to delegate to a retailer. So that means each of the manufacturers will make his channel structures decision. Okay, whether to delegate or to integrate. If the manufacturer delegates to a retailer, the manufacturer will set the wholesale price and the retailer will set the retail price. And that's exactly what we have observed in the channel pricing game or the supply chain pricing game. Okay? And each of them will decide whether to downwards vertically integrate. Okay? As a manufacturer, the retailer is my downstream players. Okay, I'm asking whether I want to downwards vertically integrate that retailer. That's my question. Okay, and again, we assume if I integrate that retail store, I can do as good as well as him. Okay, so that's the assumption. So it's a combination of a Bertrand game and the channel pricing game. And when we mix these two games, we generate new insights. So there will be three possible industry structures based on our assumptions. The first one, we call it pure integration, or the II structure. So what's that? A manufacturer, the other manufacturer, both of them run a retail store. Okay? Because this is under integration, you may treat them as some kind of total system. Okay, so there's one channel, there's another channel. And we know that these guys will set prices and the price will affect demands. Here the notation and the symbol here means as a retailer system 1 will make the retail price decision. Okay, and that price is going to affect its own demands and the other channel's demand, the other product's demand. The same thing happens to the system offering product 2. They decide the price for product 2, and that price will affect the demand for product 1 and product 2. Okay, so in this case, there is only for each channel there is only one decision to make, is the retail price. Okay. Another possibility is pure decentralization, or the case DD. In this case, there is a manufacturer, another manufacturer. They now delegate to independent retailers or franchise stores. Okay? And the franchise stores will make their pricing decisions, again, to affect the demands for both products. But here, the decisions to make, there are 4 decision variables. manufacturers need to decide the wholesale price, and the retailers need to decide the retail prices. Okay, so in each channel there is a channel channel pricing problem, and at the market there is a merchant pricing game. The last possibility is about a mixed industry structure or a mixture. It may be ID or DI, and somehow that's just an opposite to each other. ID means one channel is integrated and the other channel is decentralized. So it would be something like this. Two manufacturers, one choose to integrate the retailer, the other one choose to delegate to a retailer. They need to make decisions about the retail price, but this guy also need to make his wholesale price decision. Okay, and in this case we were going to assume that first this manufacturer makes the wholesale price decision, and then the first system and the second retailer makes the retail price decision. Okay, so again and there are three players need to make the decision. So in any case, this is a dynamic game with embedded static games. The highest level game is the game for the two firms to select channel structures. Once they have chosen their channel structure, they will start to play those pricing games. Either there's only one stage, or there may be more than one stages. Okay, but in any case, you will see at some stages, people need to do decisions simultaneously, and that's those embedded static games. Okay, so now let's use mathematical notations to introduce the model. So we know two manufacturers, each may have a downstream retail store, and that store can be a company store under integration or a franchise store under decentralization. The demand function is exactly what we have learned in a merchant competition. So the quantities Q1 and Q2 are the demand for product 1 and 2, and the P1 and P2 are the prices for product 1 and product 2. Here, theta is a number between 0 and 1, and it measures the substitutability between the two products. If you read the paper, there are several things I need to tell you. First, in the paper, at the beginning, the model is not like this. It is a more general model with 6 parameters, I believe. Okay, there are some other parameters, and then the paper shows that we don't really need such a general model, because that can always be reduced to this simple model. Okay, as long as we do some scaling, then scaling or normalization, then eventually all we need to care about is the substitutability coefficient theta. Okay, so you may check that in the paper. Also, here in this simplified model, theta can actually be 1. There's no reason to exclude 1 from the possible domain of theta. Okay, so if you ask this question, you may want to check the paper, because in the original, more general model, theta just cannot be 1, because there is a 1 minus theta in somewhere of the denominator of some ratio. Okay, but anyway, after you go through all the videos and derivations, you will see setting theta to be 1 or disallowing that does not create any difference. Okay, that will not affect our results. Okay, so because we have several different structures, let's deal with them one by one. Suppose they choose to both integrate. Then manufacturer I need to set the retail price PI. To solve this problem, he wants to maximize his profit, and that profit will be the unit price times the total demand, the total sales quantity. That's his the channel profit, its own profit. Okay. Here we, after normalization, cost will goes away. Producing each cost, producing each unit takes no cost. So that's the situation. Okay. Pi II here is the profit of channel I under integration. And because this is integration, that means the manufacturer's profit. On the other hand, if both of them choose to do decentralization, then in the first stage, the manufacturer will set their wholesale prices. And to solve this question, the wholesale price times the quantity is the manufacturer's profit. And then the retailers will, based on the wholesale price, to set the retail price. And in this case, the profit margin is Pi minus Wi. And they know Pi is going to affect their quantities, and they maximize their the retailer's own profit under these wholesale prices. Okay, so this is DD, the first stage, static game, and then the second stage, static game. Finally, there's a possibility for a mixed structure. So under ID, which means firm 1 choose to integrate and firm 2 choose to decentralize. In this case, first, the upper level part, the manufacturer 2, needs to set his wholesale price to maximize his own profit. After observing that, the other manufacturer and the downstream retailer sets the corresponding retail prices to maximize their profit. Okay. Here, the manufacturer's profit is again the retail price times the quantity, and for the independent retailer in channel 2, there is a wholesale price must be taken into consideration. The last possibility, DI, is certainly similar to ID. You only need to relabel 1 as 2 and 2 and 1, that's all. So now we have defined all those games. If we want to complete our analysis, we need to do backward induction. Okay, this is the standard method we need to use for dynamic games. And in this game, somehow there are, in some sense, 3 levels. In the first stage, they decide channel structures. And then in the second stage, wholesalers need to decide wholesale prices. And certainly if the structure is II, there is no such stage. And finally, in the last stage, retailers need to decide the retail prices. Okay? So we need to solve this dynamic game in a backward manner. So later we will first solve those pricing games, and then in next lecture we will solve the channel structure game, which is the main thing we need to discuss in this lecture. Okay, so let's deal with the pricing game. So in the paper they provided this illustrative analysis, which is the game under the DD structure. Okay, so let's go through it. Two manufacturers, both of them have chosen to do decentralization. In this case, we have this DD structure, and that's solved for the equilibrium outcome. First, we need to define the retailer's utility, and here we implicitly assume they care about profits. Okay, they are risk neutral, but actually you can see it doesn't matter, because in this case, demand is certain. Okay. Demand is not random at all, so it doesn't matter whether they are risk neutral, risk averse, or whatever. They just want to maximize their profit. So the profit of the retailer I depends on its own price. Okay, and it will be the price, this profit margin times the quantity, and the quantity can be expressed as a function of its own price, the competitor's price, and the substitutability coefficient theta. Okay, and At this stage, certainly those WIs have been fixed by the manufacturer, and the two retailers need to solve this problem, choosing a P to maximize its profit. So we want to find a Nash equilibrium, and the pair of prices is the Nash equilibrium if those prices satisfy, the first order condition. Okay, so we take retailer I's problem, the profit function, take the first order derivative, we get a function. If we plug in pi star into that function, it must be 0. Okay, otherwise this cannot be a Nash equilibrium. Okay, so we do that, and blah blah blah, we get this. Okay, and you may want to verify that by yourself. So because for each retailer we have one equation here, now we have two equations with two unknowns. W here are fixed and W is unknown. W is known. W has been observed by the retailers. So we have two equalities and two unknowns, and we can solve for the unique Nash equilibrium to be something like this. Okay, Pi star is a function of Wi's and theta. So before we move on, let's think about these equilibrium retail prices. It tells us something. First, Pi star will go up when Wi goes up, and actually Pi star will go up when the other wholesale price goes up. Okay, you probably want to think about whether this makes sense or not. So if my supplier makes a higher wholesale price, I need to also increase my retail price. Makes sense. If my competitor's supplier increases the wholesale price, what's the reason that I also need to increase my retail price? This is something I want to leave to you for consideration. Okay, so let's continue. Here, if you compare the coefficients, because theta is between 0 and 1, so Wi, the coefficient 2 is higher than theta, the other coefficient. So my supplier's wholesale price has a larger effect on my price than my competitor's wholesale price. Okay, somewhat makes sense because my wholesale price and my supplier's wholesale price is more direct to me. And finally, you may want to check if theta is 0, this price should go back to what we have observed in the single channel pricing game. Okay, I hope you will verify that by yourself, and indeed this is true. So given these prices, we will be able to find the equilibrium demands. All we need to do is to plug in these two prices into the demand functions. You will get something like this. And again, I hope you will want to verify, intuitively convince yourself that these quantities make sense, because you may go through all those verifications here. Okay, anyway, the idea here is that we have an analytical closed form expression for demand quantities as the functions of those wholesale prices, and that's how we may solve the manufacturer's problem. So now the manufacturers need to make their decisions, and at the first glance you may conjecture that this is a single decision maker problem. Okay, because as a manufacturer, it seems that I don't need to care about the other guy's decision because we are not really competing. But because my decision, the wholesale price, will affect my retailer, and your wholesale price will affect your retailer, because our retailers are competing. So in some sense, we are indirectly competing. So that's why, again, here, we still have a game to solve. I again want to write down a manufacturer's profit function, is its wholesale price times the quantity we have just found, and the manufacturer wants to find a wholesale price to maximize his profits. Again, if we have a pair of wholesale prices to be a Nash equilibrium, they need to satisfy the two first-order conditions. So again, here we have two equations and two unknowns. After you solve it, you get the unique equilibrium wholesale price. Okay, and you will see that the wholesale prices will be the same. Okay, so we have the equilibrium wholesale prices. Plugging this back to the originally obtained retail prices, we can also find an expression for the retail prices. Then, of course, we have the equilibrium demands, and the manufacturer's expected profits can also be found as a function of theta. Okay, because in our game, theta is the only parameter, and it is not surprising that the manufacturer's profit is affected only by theta. Here, if you want, or if you read the paper, the retailer's equilibrium profits and the equilibrium channel profits can also be found. The equilibrium channel profit is nothing but the sum of the retailer's profit and the manufacturer's profit. It all can be solved. Okay, so this is how we solve this game. We know that there are other structures, for example ID, DI, and II, and if you want, you may all solve them following the same backward induction idea. And actually in II you don't need to use backward induction at all, because in that case it's just one single static game. Okay, and that's nothing but a more complicated Bertrand competition. And after we solve all the four structures, we get 4 pairs of the manufacturer's equilibrium profit. These 4 pairs of profit will be our basis for solving the stage 1 channel structure game, because manufacturers choose structures to maximize their eventual expected profits or equilibrium profits. Okay, that's the topic for us, the task for the next slides.